Do you feel the vibes?
What's up, everybody? This is Dan from the Recreational Engineer, welcoming you to part 3 of the Building a Quadcopter series. In today's episode, we're going to be making some major progress. We're going to be seeing some exciting things, and we're finally back from the shop with all of our parts cut. We have our chassis plates done, we have our carbon tubes trimmed, and we have our inboard lugs machined and cut on the water jet. We've also finally finished the long-awaited shipping delay on a lot of our store purchase components, so we finally have our motors, our motor mounts, batteries, flight controller, all the other things we're going to need to finally get this bad boy in the air. So make sure you stay tuned to the very end of this episode, because I'm going to show you guys how I got all the way to this state and what happened when we tried to do an inaugural test flight. So stay tuned, I'm going to show you guys how to put this all together. Now, in order to secure the electronics, what I did is I went on Amazon and I ordered a big pack of M3 Nylon Standoffs. If you want to know where I got these, you can look in the description below. Basically, it comes with a whole assorted kit. It comes with double male ends, double female ends, male and female ends, and it gave us a perfect selection to kind of mix and match and figure out what was going to work best. Right now, what you see is I'm just taking a pair of snips and I'm trimming all of the standoffs down to size, and once I do that, I can just thread them into the chassis. By using aluminum for the prototype, I was actually able to thread into the holes. And now here I'm just going to attach the flight controller, and it actually worked really, really well. A super elegant solution, and I think the entire pack was only roughly $5. So now that the flight controller is all attached to the chassis plates, the next step was to take the ABS inboard lugs that we made in the past episode and use them to adhere both sides of the plates together. So what I did before was I drilled a couple holes in here and I tapped them to a imperial size, a 1024, and the reason why I went to an imperial size was because I found that by using metric hardware, I really wasn't able to get a coarse enough thread. When you tend to use really fine threads in plastic, you risk stripping them when you put a lot of torque on them, and I wanted something a little bit beefier, and a 1024 is a really standard size, and so that's why I went with it. They're really cheap. And so what I'm doing here is I'm just kind of putting everything together very loosely. I'm not really tightening anything down, and I want to do that way when I put the other plate together, that everything can kind of line up before I tighten it. For the receiver here, I just took some masking tape and just attached it to the plate. This is definitely not a permanent solution. We're going to have to figure out something later, but for now it should suffice just to hold everything together until we know it's working. So with all those attached, we can take the bottom plate, put this on. You may notice that I have some electronics here. All this is here is just a power distribution board. It's a really cheap $2 PCB. It gives you a place to put your battery leads into and then distribute them out to your ESCs. You don't have to use one of these. You can kind of bridge everything yourself, but it's going to save a lot of time for you. Now, the major reason that I was so held up doing this episode is because I was waiting for these bullet connectors to come in. So the motors that I bought didn't actually have connectors on the end, so I had to order some 3.5mm bullet connectors separately. But once I got them, it was a breeze to get everything going. These bullet connectors are actually really, really easy to solder. They have a little hole for you to put your iron through, kind of heat up the whole unit and just fill the little cup with solder. I will say, if you don't have a set of helping hands like this, you're definitely going to need some, because otherwise I don't even know how I would have been able to do this. But once you do, they're quite easy connectors to get ready. But once that's done, you just solder them up, heat shrink them, and you're ready to rock. So I've also done all the ESCs, as you can see in the background. Those needed bullet connectors as well. Once that was all done, I brought it over to the table and I wanted to start test fitting the arms, slide them into the tube clamps. Everything actually fits surprisingly well. The fit was nice and snug. It wasn't too tight that I had to use a screwdriver to pry it open, but I think with a little bit of force on the pinch bolts, these things should hold real tightly. Now, last thing before we can start moving on to some electronic stuff is to get all the ESCs actually hooked up. So I actually used Ultra plugs for the ESCs. I didn't want to use XT60 connectors because I already used them on the batteries and I had a couple of these left, but they provide just basically a similar connection. They're not going to be unplugged and plugged in as frequently, so I figured it wasn't as pertinent to use a really stiff connector like an XT60. And then once that was all hooked up, once I did all my bullet connectors, I'm just going to zip tie them to the arms. I know we want to actually do a very elegant inboard solution for these ESCs, but just for now, just to see that everything's working, I figured it'd be quite a lot faster just to put them on the outside, and then we can kind of put them in later. These ESCs are actually meant to be secured with zip ties, so it wasn't the worst solution, but the holes still need to be drilled in the chassis, so the whole thing's going to need to be taken apart again. I just want to make sure everything is working. But once that's ready, once we do our little test here, then maybe we can move on and do that in the next episode. One of the last things I did before the initial flight was I decided to make some pretty rudimentary feet. So as you can see, I just have these bent aluminum sections and they bolt onto the same locations that the tube clamps mount into. And although they're pretty hack looking and not really even at all, the only purpose of this was just to give my quadcopter something that would at least have some spring and something to sit on. Of course, once we finish up with this prototype chassis, we're going to be getting rid of pretty much all the aluminum. But for now, let's give this thing a shot and see how she does.
It worked.
Well, I'm not going to try to. What's the worst that can happen?
Might as well throw it off the top. I'd say top of the building after all this. Whoa.
Jesus fuck.
Ow!
So unfortunately, that didn't really go as expected. I was really hoping that I might be able to get it up and fly a little bit, but if I'm being honest, I didn't really do any tuning at all. I just hoped that it was going to work. Now, I do think that there was a bit of a problem with our flight controller from the beginning because I swapped in a different NACE 32 and found that all the motors ran a lot more consistently than they did with our board. So in the next episode, I'm going to be getting the new flight controller in, and I'm going to be showing you guys how we can actually look into the PID tuning and make sure that everything's calibrated and make sure that everything is running smoothly before we have another catastrophic failure like that. So if you guys liked this episode, give it a like. If you guys have comments or you saw things that I didn't do right, make sure you let me know in the comment section below. And if you don't want to miss part 4 of the Building a Quadcopter series, make sure you subscribe to this channel. But for now, I'm Dan from the Recreational Engineer, and I'll catch you guys in the next episode.